First thing we want to do when we're solving a rational equation is find that least common denominator, that LCD. All right, here in the first term here, I've got a denominator of x minus 4. The second term doesn't have a denominator, nor does the third, so they're effectively a denominator of 1. Either way, in this case, that least common denominator is just going to be the x minus 4 that we found in the first term. The second step to solving a rational equation is to multiply both sides, and in fact multiply every term on both sides by that least common denominator. So let's work on the left side first. I started out with 3 over x minus 4 plus 5, and I want to multiply both of those terms by the least common denominator. So I'm going to go ahead and write that in. And then on the right side, I started out with x plus 3, and again, I'm going to multiply that term by x minus 4. So here I want to take a look now and see if I can simplify things. And on the very first term, it looks like I can. I've got an x minus 4 in the numerator and the denominator, so I'm going to cancel those out. But that looks like about all I can do as far as the canceling. So now working from left to right, I'm going to go ahead and start working out this problem, simplifying, and eventually we're going to be able to solve for x. Here I've got a 3, and then what's left after that on the right side, if I distribute that 5, I get a 5x minus 20. And then on the right side, I'm going to go ahead and expand out these factors. And when I do that, I get x squared plus 3x minus 4x minus 12. All right, let's keep on working through this. We want to solve for x. So first thing I'm going to do, I'm going to start combining some like factors here. I know I've got some like factors here I can combine and also there. When I do that on the left side, I've got 5x minus 17, and that equals x squared minus x minus 12. All right, if I subtract the 5x from both sides and add 17 from both sides, what am I left with? I've got 0 on the left side, and I have x squared minus 6x plus 5 on the right. All right, this looks like I can factor it. And indeed I can. So the two numbers that multiply to 5 and add up to 6 are 5 and 1. And when they're both negative, they add up to that negative 6, which is what I need in that factor. So how do I solve this? When I've got a factored form, it becomes pretty apparent that the two solutions are x equals 5 and x equals 1. So we have two solutions that we found for values of x that solve this rational equation, but we're not done yet. Remember, we've got to check for any extraneous solutions. So to check for that one by one, I'm going to take our values of x that we found as the solution, plug them in all the way back up in the original equation that we found. If I plug in a 5 in here, I have a denominator of 1 plus 5 and 5 plus 3. Everything is fine there. The key is not to plug in a value for x that results in a denominator equaling 0. I don't have that for x equals 5, so this is an okay. This is a valid solution. What about x equals 1? Let's do the same thing. Plug in a 1 for x here, and again, I've got a denominator that's not 0, so that is okay. So we have two valid solutions here of x equals 5 and x equals negative 1.